Here is a great example of an unrealistic problem that was made just so that you could have a problem that uses your new skills to solve. So look at this. Clara and 3 friends were born on March 11th. What a coincidence. Leslie is 5 years younger than Clara. Mike is 2 years younger than Clara. Thomas is 3 years older than Clara. And you happen to know that on March 11th, 2011, that the product of their ages was 61,136 greater than the sum of their ages, but for some reason you never bothered to ask them how old they are.
I don't care.
Right? This is a very realistic word problem. Not at all. But we can use, this is one designed, just let's make up a silly example so you can use your new skills. This is one such example. Because in real life, if you wanted to know how old they are, you would ask.
Exactly.
Right? And then this question would be done. And you would also go, this is really weird that you were all born on March 11th, but we're not going to get into that. Yeah. It's just the product of their ages, so ages are probably measured in years, okay? When you're younger, you can go by months or weeks and things like that. But usually when you're older and someone asks you, how old are you? If you give the answer in days, you never make a friend. It's just doesn't work out well for you. So we need to make some decisions of what we're going to show for this. In this case, it makes sense to make Clara's age X, because everybody is compared to Clara. How old is Leslie? 5 years younger, so how would I show that with X? X minus 5. And then we've got Mike. Mike's age, he's 2 years younger. That'll be X minus 2. And Thomas is 3 years older, X plus 3. So this example is good for getting you to the idea of how can I compare all of them with the same variable. That is something that is a useful skill in useful real-life problems. So that's good, even though this isn't a useful real-life problem. And now we get this complicated sentence that allows us to create an equation. The product of their ages was 61,136 greater than the sum of their ages. Sometimes with complicated things like this, we can start with our equation. I have my product over here. I'm just going to write it in words, and I'm going to have my sum over here. How am I going to put that 61,136 so that they're equal? Should I put plus 61,136 on this side, or plus 61,136 on this side, or should I use minus? What should I do?
It says that the product of their ages was 61,136 greater than the sum of their ages. You take the sum of their ages and then add.
Right. So does it make sense that the product is the bigger number? This is the smaller number. And then since this one's greater by that, you would have to add the 61,136 on this side. So now what does this look like? Well, the product means you would multiply all these together. Oh my goodness. You'd multiply all those together, and the sum would be adding them all together. Mental math's not too bad here. Can you see that if you add them all together, you're going to get 4x, adding my numbers together, minus 4? Is that okay? And then I still have plus 61,136 here. So now there are two ways that we can use our graphing calculator to solve this. One way is to keep things exactly as they are. Plug the one side into y1, plug the other side into y2, and find out where they cross. And so if I do that, this is what it would look like. X times x minus 5, x minus 2, x plus 3. That is my left-hand side. On my other side, I have 4x minus 4 plus, and I didn't even simplify it. I just typed it in exactly as it was. Now, when you hit graph, chances are you won't see either of the graphs, or you might not see where they intersect at all. Maybe you do, depending on what your window is. So I've got my blue graph, and apparently I can't see the other graph whatsoever. So a couple of things you could do on your zoom. Some people like to do zoom fit. Because it should show both graphs. Sometimes this also doesn't give us a very nice scale. So there's my one graph. Oh, and there's my other graph. Can you see where they are going to intersect? Somewhere over here. You see the red line's going this way, the blue line's swooping up, but they're still off the screen. So what I'm going to do is I'm going to go to my window now and manually do some things. I'm going to make my X max bigger, maybe up to 30, and make my Y max a little bit bigger, 65,000. Now you hit graph again. So my blue graph is swooping up. My red graph is going more or less straight across. And they do intersect. So at this point, I can go second, calculate. Number 5 is where do they intersect? Push enter on the first curve, enter on the second curve, enter when it says guess. And we find out that X is 17. So Clara is 17 years old. And you could find out all the ages of the others. So Claire is 17, Leslie's 12, Mike is 15, and Thomas is 20. Yes? It's where the two intersects is where the X value is the same and works for both of them, and that would be your solution. The other way the textbook does this question is it says, what would happen if I made one side equal to 0? So I would have x times x minus 5 times x minus 2, wow, times x plus 3, subtract 4x minus 4, subtract 61,136. And if you made the whole side equal to 0 and typed that big thing into your calculator, so I'm going to go back to y equals, I'm going to just turn that graph, second graph off, and go to my first one and add. What would happen if I subtracted everything over to the other side? So can you see, if I move that y2 over to the other side, I would have minus 4x, right? If I move the 4 over, it would be plus 4. If I move the 61,136, that would be minus 61,136. You see how I just moved things over to the other side of the equation? Now, when you graph this, you are also going to get a crazy function. But now what you're looking for is an x-intercept. So what I'm going to do is I'm going to go to my window. I'm going to use some common sense. I'm going to say I'm finding an age. Chances are they're somewhere between 0 and 100. That seems reasonable. Okay? And now when I hit graph, okay, I'm wanting to find an x-intercept, so I don't need to go up to that high. I can just go up to 10, maybe start at negative 10, because I really want to see my x-axis. And I hit graph, and I'm not going to see much of a graph at all. Probably, whoop, there's a straight line. Do you see that you have an x-intercept? Somewhere about there. So you can go second, calculate. Where is that 0? Left side 5, right side 20. My line's in between there, and it finds my x-intercept at 17. Okay, questions you can do for this one are 7 and 8.